Hello and welcome to this video about Sitecore and Kubernetes. Specifically in this video I'm going to talk about what's next after you've played with Sitecore locally. I mean, you've followed the guides, you've installed Docker locally, you've spun up new Sitecore 10 instance running on containers, and you're thinking like, yeah, this project I'm working at right now is gonna be finished soon, and I'll need to run this in production. And the question arises like, how do you run it in production? Well, apparently you cannot run Docker Compose, which you've used locally. You cannot use it to run it in production, your solution. And how do you do that? There are plenty of options, but the most standard one is obviously using Kubernetes to host Docker containers. And even further, like you can host Kubernetes yourself on your own hardware. You can use Azure Container Services. There is Kubernetes hosting in Google Cloud, in Amazon Web Services, and lots of options. Like obviously, as a Microsoft stack engineer, you'll probably use Azure, but it can all of this what I'm going to talk about today is going to apply to other hostings because it's still Kubernetes under the hood. And I will talk about experiences of our team. We've been doing Kubernetes deployments since 9.3 version of Sitecore, and we've deployed to both QA environments and kind of pre-production environments. And also, what is production for us? It's a demo environment. So we have experience deploying more than 600 different sales demos in production. And I'm going to talk about some tips and tricks and some common issues which we've encountered over the past half a year or even more. So I'm not going to talk about installing Kubernetes or setting it up in Azure. You can find a lot of guides about it, and yeah, this is completely different topic by itself. But I will focus specifically on issues and some nuances of running Sitecore inside Kubernetes. So how do you get started after you want to deploy stuff to Kubernetes cluster? There is actually official Sitecore guide on how to deploy to production. It's called Installation Guide for Production Environment with Kubernetes. You can find it at dev.sitecore.net. It's the same page where you've downloaded Sitecore Experience Platform version 10. And if you download that package, you will see this folder. You've probably used it to deploy containers locally. And there's a Kane8s folder for Kubernetes. And you can see configurations and deployment files, which are called Helm charts for Sitecore XP1 configuration. It's basically what's going to be deployed. It's a definition of the deployment in Kubernetes. To some people, this is something similar to ARM templates because basically these files define like what needs to be deployed and how it's going to be deployed, some variables, and yeah, it's completely different syntax. So, but yeah, you might find it similar. And once you have your Kubernetes cluster up and running, and in this example, I will use Azure Kubernetes Service, you will be able to connect to this service in multiple ways. So first one, you click connect here, and you will see some quick connection commands. Basically, you need to set account subscription to the right one, and this is especially important if you have access to multiple subscriptions. And then there is a simple command called az aks get credentials. You specify the resource group and the name of the cluster, and basically you're in. After you've done that, you can go to the PowerShell console or just command line, and you can use a command which is called kubectl, which is basically replacement of your Docker Compose command. So you've used Docker Compose up, down, and many other commands, and to connect to your container, you will see in future that this command says really similar syntax. And I've connected to the cluster already, so I can use, for example, one of these commands, which are listed as samples. So kubectl get deployments. I will just go here. I will edit. Yep. And you see that I'm connected to the cluster. I have some deployments in different namespaces. In my case, I have two deployments in custom namespaces, and this kube system. These are all the system containers which are used by Kubernetes itself. So all this kind of dashboards, autoscalers, Nginx controllers, yeah, all of that you can see what actually runs under the hood of Kubernetes. So this is one way. There are also some tools which you can use. One of them called K9S. If you Google it, you will find this one. It's basically Kubernetes CLI, which I would actually call UI. It's console-based UI for Kubernetes. If you don't want to remember all these kubectl commands, you can just use K9S, and you can do pretty much everything you want. You can see all the namespaces, all the pods, all containers. You can edit them, you can attach to containers, all within one tool. And for example, here I have, let's say, what I have. I have my SQL Server container running here, and I can see at the top. I can attach to this container, I can delete it, I can describe it and see how it looks, I can edit it, and yeah, lots of stuff. Like, for example, if I press A, or no, I can press S to enter the shell. Let's write it out. Yep, see, I'm in, and I can interact with my SQL Server. So exit for now. So plenty of options. And other one which desktop Windows users are gonna like, it's called Lens. It's also an open source tool, so you can find it on GitHub right here. No, not this Lens. Yeah, it's a bit harder to find this one. Kubernetes Lens. Yes. So this one, it has really nice UI. It's also open source. So yeah, you can contribute, you can watch its development. And basically, these tools, K9S and Lens, I would say they have feature parity. You can do the same stuff with both of them. And under the hood, they still use the same tool, which is kubectl. So basically, both of these UI tools are just, yeah, making it easier to work with your mouse, and you don't have to remember all the commands. And for the starters, I would recommend Lens because it lets you explore your cluster without having to remember some shortcuts you would use in K9S. So here you can see exactly everything you have here in the cluster. You connect to the cluster, and yeah, you have everything here. And Lens is super simple to start with, so you just install it, and then once you've ran all of these commands, basically this command here, get credentials, then you go to Lens, you go to add cluster, and the cluster you've downloaded credentials for, it will be already available in Lens. You just add it, it appears here, and you see all the nodes, which are virtual machines, which are managed by all clusters, all the pods, deployments, and just everything you want to work with. And speaking of common issues you might see in Kubernetes. So first of all, you need to set up performance of your VMs accordingly. So Kubernetes is not going to do it for you. Like, you have to create your node pools manually or using PowerShell scripting, and you choose a size of your VMs. Like, you choose a type, like it's gonna be Windows VM, and you can choose a size. Basically, you need to have decent number of CPUs and memory, and of course it depends on your configuration you're gonna deploy. Like, is it XP1? Maybe it's XP0, maybe something in between, but you will see in these files what can I see here? Okay, it's not here, but requests. You can actually specify, and you have to specify the number of the amount of resources available to your containers, specifically for each of these containers. So CD, CM, like here, I will show you some example. Yes, so like this. You have to specify minimum amount of CPU and memory available to each container. And from my experience, I would say it for CD and CM, it must be at least 1 or 2 CPUs as requests. And limits, you don't have to set them actually, but on average, you should expect like 1 or 2 CPUs for CD and CM. Memory depends on your solution, but usually it's like 2 gigs or 3 gigs of memory is just enough for running content delivery or content management server in Kubernetes. But again, it depends on your solution, amount of items, cache sizes, and yeah, lots of other stuff. So if you actually, I'm gonna go back here. So if you choose a smaller VM, let's say DS1 or D2S, it will still run. Like, it will create, let's say this machine has 2 vCPUs, and you have CD, you have CM, you have publishing service, you have lots of other containers, and altogether they need 6 CPUs total. Then what Kubernetes will do, it will create 3 virtual machines of this size, because this is the size you've chosen when you created the node pool. But as you can say, it's inefficient, because why would you would pay more, and why would you manage multiple virtual machines instead of creating just one? It again, it depends on your requirements. Like, but if you know exactly that this is the amount of resources I need for one instance, then yeah, why choose smaller VM? Like, and again, if you know that you're gonna host multiple instances, like, I don't know, like 3-4 instances of Sitecore on each on your cluster all the time, then yeah, you can go with D8 with 8 CPUs or even higher specs. Yeah, so just choose it wisely. It's possible to change it in future, but you have to recreate the node pool. It's not something that you can do on the fly. And if you go back to the node pools, yes, it can scale automatically, but it's like horizontal scaling. So you can scale the number of nodes from 0 to as much as you want. You can have manual scale. This means that like this number of VMs will automatically be created and always waiting for you. But yeah, if you drop and create new instances, then yeah, why not have auto scale? It will create VMs of this size each time it sees that it needs more resources. So this is all going to be handled by Kubernetes, and there's not much you actually have to tweak yourself. It's going to work pretty much out of the box. So also related to performance and CPU, if you set CPU limits or memory limits too low, well, for example, let's say we set CPU limits too low. What I saw, for example, for publishing service, I once set CPU limit for publishing service to 10% of one CPU. Yes, you can actually set it. It's not just integer values like number of CPUs. You can assign like half of the CPU or 1% of the CPU, one CPU core to a specific container. But if this value is too low, yes, you might have some issues. For me, it was the container was just starting and then suddenly failing. And once I increased this value to 200s or 300s, like 30% of one vCPU, it started working. But again, it depends on the node size, of the size of the VM, CPU it uses, and also it might be specific to the Kubernetes version you use. And in this specific case, I'm using 1.19, and new versions of Kubernetes get added to Azure all the time, so you might have newer version with some bugs fixed. And the same issue with memory limits. Like Sitecore by itself, it's not, I would say it wasn't designed from scratch to handle situations when it gets killed, when it's running out of memory and gets recreated quickly. It takes a while to, let's say, recreate CM. So you don't want the situation when your CM runs out of memory available to it and it gets killed by Kubernetes scheduler. So you add some extra amount of RAM it can use. Like if you know it's gonna use like 3 gigs of RAM, just set 4 as a limit. So to be on a safe side, so it's not gonna fail suddenly, because yeah, if it's gonna use slightly more than the limit, then it will get killed, and it will start automatically, but it's not what you want for production server. Also, if you look at some popular Kubernetes, or not just Kubernetes, just Docker images, you see that they have tags at the end. Let's say if I go to SMTP one, which is external, we just happen to use it in our project. But what we have here, what is maildev? Well, this one, it's using image maildev, no specific tag, but you will see often that they have tags like stable, latest, and at first you might think like, hey, I can use the same tagging strategy for my website deployment. Let's say latest is my develop branch and stable is my main branch, and like I build it and it gets updated automatically, and don't do that. Like seriously, you'd better assign specific tags and unique tags to each image you build for multiple purposes. Like you might want to have rollbacks to the previous version, or the issue we encountered is Kubernetes can, at some points, like if it's rearranging containers on different VMs, if you have your website running, at some point of time, some of the containers can get killed, and recreated, right? Let's say I will kill this one. Yep. So this one, it no longer exists. It gets created from scratch. And when it's created, if you go to the log files, you will see that it will pull the latest version of the image it's using. So you may end up with a situation when your production website is running on some specific build and you've built a new version. You're not deploying it to production yet in any way, but if container got recreated, it will automatically pull the newer version. And if you get version mismatch, let's say between your content management and content delivery or some other container, you will have some issues because of this inconsistency. So what you definitely should do is use specific tag, like in this case, I have this, the tag here is a like version of the software, version of the operating system, and what you really should focus on is this. This is the version of the software. It's a beta version, and it's the .11. Like even beta versions have specific tags, and if it will get recreated, it will still use this specific tag. It's quite important, and it's super easy to set up. For example, for any build system you use, whatever, there's a tool called git version. This one. You basically install it. Actually, you don't even have to install it in your project. You add it as a build step in Azure DevOps, in TeamCity as MS build task, and it will automatically tag your software based on its current branch in Git, or is it main, is it develop. You can specify some custom rules, but even out of the box, it will give your software new version each time you push something, you get a new version. For example, here, if I push something else to develop, it will change the version from 11 to 12. It will do this automatically. You don't have to do anything. Like it will just work, and you'll be safe with all of these versions and everything. Also, it's quite important that you, when you deploy all of this stuff, you can find, let's say, look at some of the charts, and you can see the probes here. It's liveness probes and startup probe. So these are pretty important ones. Like, make sure you don't remove them, because in some cases when, first of all, when Kubernetes is relocating containers between the nodes, it doesn't have to happen. It might not happen for you in your specific scenario, but it might happen. Yeah. If you have the live probes, it will not just kill the container and wait for another one to spin up. It will actually spin up a new container side by side with the old one, and when the new one is live, it will kill the old one and will replace it, and everything will work smoothly without downtime. It should. And second use case is if some container stops working. It happened to us with XConnect container a few times when we didn't have this liveness and readiness probes. And Kubernetes is smart enough to understand that, hey, this container is not healthy. I'm gonna kill it and create it again. And this actually gonna save you a lot of time just troubleshooting production issues when something is not submitting. Because, for example, if XConnect is dead, then your form submits on content delivery might not work, analytics will stop working, and yeah, you might have quite a few other issues. And also, one of the common issues is when you deploy something to Kubernetes, but your deployment is not progressing. For example, everything looks like this, like this, like this, like this, like this. And you see that some containers are creating, some are waiting, and you don't know what's happening. Yes, you can go to events, you will find out in this tool or in Lens. It will tell you roughly what's going on, but not always. And if you see something like this and nothing changes, then you might want to go to your cluster again and actually check the node pools. Maybe you set the scale, auto scale to some really low value, like max of 2 VMs, and you have 2 VMs already. Current node count is equal to the maximum, and it will not scale, obviously, and that's why it will not assign your containers, and you will not be able to see like new deployments. But there's another potential issue. If you have a lot of nodes, there are actually some limits on a subscription level. So for example, by default, you cannot deploy more than X number of VMs of specific type in a single subscription. You can change that by sending a request to Microsoft, like, hey, please increase this limit from, I think like default one is 20 VMs or maybe less to some other value. But just note that even if you set auto scale to 200 instances, it doesn't mean that it will scale to 200 instances. There are still limits in other places in Azure. What else? One other issue we encountered is environment variables. So in this specific case, like, what do we have? SMTP. We don't have SMTP. Environment variables. I'm gonna. Oh wait, actually we do. Environment. Oh no, not here. Yeah, maybe describe this one. Yes, so you can pass environment variables just like you do with Docker Compose to AKS clusters, and there are some things which you should be aware of. The first one is that the name of the environment variable, so this one, can only contain letters and digits and underscore. It also cannot start with digit, as far as I remember, and also it cannot contain colons, which are widely used in .NET environment variables to like structure them. But yes, basically what you should do is to use underscores, and Sitecore in its connection strings and other properties, it actually allows you to use double underscore instead of colon character, and this kind of fixes it. And also, you cannot like out of the box use some special characters in these values, like in the values of the environment variables. If it's a special character, and you can also Google like which characters are special, you have to escape them. There are built-in functions in Helm when you build these charts, which allow you to escape the values, or you can follow the way Sitecore does it and actually pass variables using secrets. So here you will not type the value directly. You will say use the value from this secrets file from file like shardmanager.txt. This will also solve it. But be aware that if you just, for example, if you go here and in environment variables, you see here you use secrets, but if you decide to do something like this, then some of these characters might not actually get to Kubernetes, and you will have some weird issues. So yeah, I would suggest just use secrets, and then it will save you a lot of time in the future. What else? Once you deploy or once you deploy a new instance or redeploy something, you might see that it takes actually a while to create a new instance, especially if it's a fresh VM. This is because it will take some time to pull the image from your container registry. And some, especially Windows images, they can be huge, like 4 or 5 gigabytes, because it's just Windows plus your custom website files and lots of other stuff. And just be aware that it might take time. In our case, as you can see, we run some containers on Linux, like SQL on Linux, SMTP, Solar. Unfortunately, I cannot run publishing service and other Sitecore services on Linux as of now, but maybe it will possible in future, and it will also save time on pulling images and also memory footprint. You can see that obviously all the Linux containers like Solar. Oh, no, that's not a good example because it's Java, but SMTP container is using just 20 megabytes of memory, right? And this custom .NET Core project which we have here, init container, it uses 36 megabytes of RAM. Compared to XConnect and some others, that's it's saving a lot of memory. And the last point I wanted to talk about is, as I previously mentioned, sometimes Kubernetes might just kill one of your containers and move it to another node. If you don't want it to happen, actually Kubernetes wants to save you money by kind of optimizing the amount of resources it uses, amount of VMs it has. But if you don't want it to happen, there is a special property which calls save to evict. It already works. Like it's just there used to be some bug, but if you use this annotation on your chart, you can set it on specific charts, then it will not do this. Like it will not move it to another VM once resources are available. It will just keep it there, even if it's not optimal. And but at least you will definitely not have downtime. You shouldn't have downtime anyway with all this liveness and readiness probes, because it will create another instance. But liveness of, let's say, content management instance, it doesn't mean that it's going to be as quick as before, because it takes time to load some caches, to populate some experience editor caches, some disk-based caches, media cache. So sometimes it's just easier to avoid eviction and make sure it always runs, and even if you don't save money as you could. So that's basically it for the start. Let me know if you have any further questions, either in the comments box below or in my blog or Twitter. Feel free to contact me, and I will try to create more guides and share them here and on my blog. See you.